Hi, welcome to today's session on real life graphs. So they are exactly what they sound like. They are graphs that are based upon real life events, in which case something happens and we actually create a graph out of it. Some type of real life graphs, they're known as conversion graphs. Good example for this, converting Celsius into Fahrenheit or vice versa. Could have a question maybe saying, what is 100 degrees Fahrenheit in Celsius? So for this, we'll look along our Fahrenheit, reach 100, then draw a line going straight away out to our line. When we reach our line, drawing a line going vertically straight down. Now, wherever this ends up, this will be our conversion of 100 degrees Fahrenheit into Celsius. So 100 degrees Fahrenheit in this case would equal 38 degrees in Celsius. Different type of real life graph is the time distance graph. Now, here this is a basic time distance graph. We've got a distance going along our y-axis, and we've got time going along our x-axis. Now, people do struggle to actually interpret, to identify what these are actually asking of the learner. What I always try and get my learners to remember is that this line going straight the way across here, this is home. At the highest point, or the further away that you get, this is the distance that you are away from home. And here, lines going up and down with different steepness. This actually tells us how fast the person or the event is travelling to or from home. The steeper the line, the quicker the speed. So this, we're using this as an example. This travelling away from home is steeper than the line travelling back to home, so they will be travelling quicker heading away from home than travelling back. So we could interpret this by, we have our start point, a constant pace until stopping just here. This part just here, where over a course of time, we aren't getting any further away or any closer to home. This is where the person or the event has stopped. So it's stopped for this length of time. And then returning home, but this time at a slower pace than what they actually went to the place away from home. I always say, if you can try and put a story to it, it does make it easier to interpret this, and I do encourage this with my learners. So we could actually use time distance graph to actually calculate solutions. So here's my time distance graph, distance in miles. So we've actually got some form of measurement there, and here is our time, and this is an example of Pardeep Cycle Road. So standard questions could be, how long did he stop for? In which case, this duration just here, where the line has stayed constant going horizontally, this is the amount of time that Pardeep went and stopped for. So this would be 15 minutes. Because going from 1:30 to 2, that will be half an hour, and this point here is half of the half an hour, so that will be 15 minutes. We could also maybe work out average speed between different times. So here I'm asking for the average speed between 1 and half 1, between 1:45 to 2:15, and from 2:15 to 3 o'clock. Now, first one I've actually started to draw out. So from 1 to half 1, got to bear in mind that there is 60 minutes in an hour. This would help us out, because the answer to this is 6 miles per hour. It's taken Pardeep 30 minutes to travel 3 miles. And normally when we're talking about speed, we're talking about miles per hour or maybe even kilometers per hour or meters per second. This we're talking about miles. So if we double this, he's actually doing 6 miles per hour. For the second one, just showing this using the green line, this is the exact same solution, 6 miles per hour. Again, over the course of half an hour, he's travelled 3 miles, so doubling this, over an hour, he would travel 6 miles. And for the very last one, we've got, it takes him 45 minutes to travel the 6 miles to get home. Therefore, if I was to put this into a fraction, then multiply it by 60, which is multiplying by the 60 minutes, we end up getting 8 miles per hour. If you found this useful, please subscribe. Thank you very much for watching.